Greetings. I'm coming from Jackson Hole to be with you. And as I was telling one of your members, Jackson Hole is just like San Francisco Bay Area, except everything's different. But I hope a couple of things in my remarks, which I'll try to keep brief this morning. First of all, my intent is that when you walk out of this talk, I'll have raised your hopes and expectations for treatment of these serious diseases. Sanjay Gupta and I both believe that the last person to have Alzheimer's disease is alive today, meaning that hopefully within many of your lifetimes, this disease will be taken care of and eliminated, much like polio. Um, Secondly, I hope to give you a little peek behind the door to see what science is like and to sort of make this startling assertion that the laws of chemistry and physics apply equally in remote parts of Wyoming as they do here at Cal Berkeley, but obviously not Stanford. I was here during the game when the Stanford band decided to play football, and we at Cal sort of all nodded knowingly. Yes, well, there's some reasons you don't have the tuba guy running for the pass. And then third, I'd really like to extend an invitation to you to come see me in Jackson Hole. We have a great laboratory, a great bunch of scientists, and if you're up our way, please call in, and I'll do my best to make you feel right at home. So that's my goals for the talk, and to get you out of here on time. Fortune sent out a reporter. They didn't think I was good looking enough on my photos. They put a silhouette. So it's sort of like getting half a bagel in the morning. But the reporter said to me, you're Paul, you're disruptive to the pharmaceutical industry. And I said, well, the last time I said I was disruptive was in second grade. He said, no, it's a good thing. So we have a very different approach to Alzheimer's disease, an extremely different approach, but one that provides a lot of hope. And let me go on here. Sanjay Gupta also brought out a team from CNN, a filming team. We are a not-for-profit organization. We're a charity. A lot of people say, why didn't you start a biotech? And the answer is we wanted to do some deep dives and rethinking about things in a way that probably would not have been appropriate in a pharmaceutical environment. We have a singular mission as a not-for-profit, and that's to improve patient outcomes. And we feel an urgency to do that immediately, and we'll tell you some things we're doing. And the charity Navigator and other rating agencies love us. We have in our laboratory 6 senior scientists. These are some of the smartest people I could find. And then we're supported by 50 scientists around the world. We get together once a year for a week. They're coming in and out all the time, and we're actually can begin experiments in Johannesburg and finish them up in Sydney, Australia that night. We are focused on protein misfolding, and this is a key concept. We, unlike all the pharmaceutical industries, are not focused on symptoms. We think that's great work and we support it, but we're totally different in that we're looking at the causes of Alzheimer's and other diseases, which are protein misfolding. So our focus is on preventing protein misfolding, diagnosing it before it happens, treating ALS, Alzheimer's, and Parkinson's disease, and some other diseases known as the tangle diseases. The reason they're known as the tangle diseases is that this is Dr. Milo Lin, who, like me, was a member of the Miller Institute for Basic Research and Science at Berkeley. He's holding a slinky. This is what I used to get as a kid in Christmas time in Wyoming. Anybody here ever get a slinky for, yeah, okay. I don't know about you, but after about 2 weeks, that's what mine looked like. I never succeeded in refolding them correctly. And that's the crux of my remarks today, is that the slinky is an alpha helical conformation, looks very much like a neuroprotein. And when they misfold, you can't get them back into the original. Here's a misfolded set of tau proteins called a tangle from an Alzheimer's patient. So there's 2 different proteins or protein fragments in Alzheimer's that misfold. One is called tau. Typically, it's sort of like the transportation network within our neurons. Second one is a fragment called beta amyloid 42. It's a fragment of the amyloid precursor protein, which plays an important role in our brains, in the membranes. ALS, a different disease, has different proteins that misfold. TDP43, FUS, SOD1, there's some others. And then Parkinson's misfolds alpha-synuclein. So what we're saying in Wyoming, and which is considered so radical, is if we can figure out how to stop protein misfolding, we can not only cure Alzheimer's, we can cure half a dozen other protein misfold diseases all at once. And I think we're the only laboratory in the world that's shooting at Alzheimer's disease by treating ALS. And if you understood what I just said, that should make sense. The reason we're focused on ALS is the patients with ALS, and I know we have people here who've had loved ones pass away from that, they decline so rapidly that clinically we can see if our drugs and our interventions are working in a really fast time. We began in Guam. I had finished, I was very fortunate. Together with my colleagues at the National Cancer Institute, we discovered a new HIV/AIDS drug. I got very emotionally attached to the HIV community. And once that started moving at glacial speed through the pharmaceutical pipeline, I wanted to find another indication that involved diseases that had been around but not well understood, no good drugs, and damaged entire families and communities. I recruited Dr. Susan Merck as a postdoc. She's now a endowed professor at University of British Columbia. Professor Sandra Bannock from Cal Berkeley, and at that time she was in the Cal State system. We had a couple of neurologists and physicians. And me, I'm an ethnobotanist. In fact, sometimes I'm introduced as one of the world's top 50 ethnobotanists because there's only 25 of us. And so my training is not to wear a stethoscope and do clinical work. My training is to sit in small villages, sit in huts, learn languages of the people, and try to understand how they use plants and what's the patterns of wellness and illness. So that we took our little team 6 times to Guam to look at 2 remote villages, Bumatic and Matitio, where 25% of the adults were dying of an ALS-like disease. Those that didn't die of ALS had something like Parkinson's. Those that didn't have that had Alzheimer's. So my thought was, these 2 villages represent a neurological Rosetta Stone. If we can figure out what's making these people sick, we might get some deeper insight into the relationship between these very disparate diseases. We focused immediately, and where's that banner of the CICAD from? Yeah, there we go. In Japanese, they call this sotetsu. Sotetsu. We got very interested in the seeds of the cycad tree that were being used by the people for flour. And I want to go with you and visit this Rotary Club. And I'm interested. I'm not surprised the trees live 400 years. I just want to know how long the locals around that tree are living. Because we found that we knew that there were aerial roots come up from the cycad trees, and they contain a bacterium which is photosynthetic. This is known as nostoc species. Here I've cut a piece of the root so you can see that little green area. That's photosynthetic bacteria. These are gram-negative bacteria. And they produce an astonishingly dangerous neurotoxin called BMAA. So when the people cake the seed kernel and make flour out of it, and they make tortillas and dumplings, they're getting a dose of neurotoxin. Even worse, when they eat flying foxes, these are large bats. The bats eat the cycad seeds, so they get a megadose of the toxin. We found that feral pigs in Guam and deer eat seeds, so they're getting multiple sources of the toxin in their diet. So the hypothesis we published in Proceedings in the National Academy of Sciences was that the bacteria produce this weird neurotoxin. It accumulates in the tree through various roots. It gets into the people and it kills them. And this man that you're seeing here is very typical of what people with the illness look like, because his face is like a stone mask. He feels all the range of emotions any of us feel, but he can't express them through his face. I should mention that as we're doing this work, I said to my team, you know, we could be deluded here. And as a scientist, it's your duty to try to disprove your own hypothesis. I said, we need new eyes. And they said, what are you saying? I said, let's go to Stockholm. I'm a member of the Royal Academy. And they set up a meeting for me in Stockholm, closed meeting for 3 hours. We presented our data for an hour and then waited. No response. I stood up. I said, look, you know, the reason we're here is I want you to tell us where we're going wrong, because we'd rather hear it from our friends than from our enemies. Sebastian Conradi, very distinguished neurologist at Karolinska Institute, stood up and said, Paul, you need to know when your paper came out in PNAS and your previous paper in neurology with Oliver Sacks, he said, that was the subject of jokes here at cocktail time in Stockholm. We had a big laugh about the idea that you eat a bat and you go batty. He said, but now we've heard the data. This is no joke. We want to help you. We want to collaborate. We want to join you in your research. Wow. So that began our consortium of scientists. You don't have to go to Guam to be exposed to the toxin. You could even be exposed in Lake Merritt. I don't know what Lafayette Reservoir is like if you ever see green scum there. If you do, get away from it. This is cyanobacteria. We've been monitoring cyanobacteria releases from Lake Okeechobee in Florida. As when there's rain and a big bloom, the Corps of Engineers has been releasing cyanobacteria-laden water down the St. Lucie River to Stewart in the Indian River Lagoon on the eastern coast of Florida, and down the Caloosahatchee to Port Charlotte, Fort Myers area on the west side, west coast, thereby contaminating tens of thousands of people with toxin. You don't have to drink the water. We've set up monitors that measure it floating in the air. Our colleague, Dr. Elijah Stommel, who's a professor of neurology at Dartmouth, and his colleagues have carefully plotted the residences of ALS patients throughout New England. They find if you live next to a lake or reservoir with cyanobacterial pollution like this, that your chance of getting ALS goes up 25-fold. So we're extremely concerned about this, extremely concerned. That work and concept's been replicated in France by William Camus at the University of Montpellier, who's a good colleague. In the Tau Lagoon in southern France, there's the people that are in the fishing and oyster industry have a much elevated risk of ALS, and it's been replicated by our colleagues in Stockholm in southern Sweden. So the one thing I'm very happy with is we've been quietly engaging the Corps of Engineers, saying, please don't do this, release this water. And Monday, the Corps of Engineers came out with a new plan. They said they will stop doing that. So we're really thrilled that we can have that public win. But it's so serious in Florida that in the hospital systems, they have a code now for cyanobacterial exposures. Emergency room docs are trained to record this and you know, people were sending us their dogs. That's what was really interesting when their dogs started dying. Man, it hit the press, and so this is no joke. And if you see that sort of discoloration in the water, please just get away. That's your best protection. Well, what is the neurotoxin? It's a non-protein amino acid. And what that means is it's not one of the 20 amino acids that make up our proteins. Our proteins are like a little train with amino acids as the cars. And so we started thinking, well, this non-protein amino acid might be mistakenly incorporated into the protein amino acid sequence and cause it to misfold. So we were looking for what it misincorporates through. In one of my John Galt talks I've given to the 50 people who've all agreed, I flew down to Sydney, Australia, to meet with Dr. Ken Rogers and Dr. Rachel Dunlop, who in my opinion had written the most cogent literature on this phenomenon. They were at the Heart Research Institute. I said, you know, it's so great what you guys are doing. Would you please stop it now and work with us on Alzheimer's. They agreed. And together we discovered that this neurotoxin substitutes for serine in the protein sequence. That's a very dangerous thing because here we see a little serine residue here. It turns out in a neuroprotein that 92% of the sites where the protein is charged are serine. That's where they're phosphorylated, meaning that's how it folds like origami so it can do its function. And if you mess with that site, you're going to get serious problems. This is a dietary amino acid. It's common in soybeans, seaweeds. And we found in human neuronal cell culture, if we added serine to the culture medium, we could stop all protein misfolding and all neuronal death. I wanted to see if that would work in animals. So this took me to the island of St. Kitts in the Caribbean. I was so proud of my scientists. It was a cold day in November. I went in and I said, look, I need volunteers to go down for a month or more to sit and babysit monkeys in the Caribbean. And every one of my scientists volunteered. I was so touched that they make that sacrifice. Here's part of our team. It's a wonderful facility. What happened was that maybe 150 years ago, 200 years ago, a sailor threw out Adam and Eve African green monkey. And there's no natural predators there, and they're called vervets. So there's now 40,000 vervets on Island of St. Kitts. They outnumber not quite 2-to-1 the local inhabitants, the humans. They're also over on Nevis, and there's actually little things on YouTube. I don't know if they're contrived, showing vervet sneaking down to the bars in Frigate Bay and stealing Mai Tais out of patrons' hands. But here they're all grouped together as a zoo. The wild vervets try to break into this place because they can get their 3 square every day there. What we did is after the meals, we offered them, and I want to emphasize that we never made an animal take a dose. We just only offered, give them a banana or a piece of guava with an embedded substance. And those that got the placebo had no neuropathology whatsoever, no problem. All those that got the neurotoxin BMAA had massive neuropathology, which exactly resembled that we'd recorded in the villagers in Guam. This is the interrhinal cortex. I've got a cursor there. And this is all misfolded tau protein. And we had sparse amyloid plaques. But then when we gave those vervets serine, we were able to block 85% of that. So this is the same result that we'd found in neuronal cell culture in our laboratory, and that was pretty exciting. This is these little dots or neurons are filled with misfolded tau. Misfolded tau made these neuropil threads. This had never been seen before in any animal model. In fact, and if there's time, there may not be, but I can get back to why the pharma companies are so focused on amyloid, and it's because they work on mice, and there's a mouse that overproduces amyloid, but no mouse produces this sort of stuff. We kept going, and we found all the ALS pathology that you'd see in a human being. These are spinal sections of placebo. Animals that had exposure to the neurotoxin had FUS, TDP43, all the protein misfolds that you see in ALS in a profound way. And so we recreated in the Caribbean every single piece of neuropathology we found in the villagers in Guam, which I think is strong evidence that this neurotoxin was triggering this disease. Now, well, thank you. Thank you. The one thing I haven't told you is one of the reasons I went to the Caribbean is that genotyping those animals, Adam and Eve vervet were APOE4 homozygous. They had a double dose of the Alzheimer's gene, APOE4, that in human beings increases your risk. So this was really important because I think this is the first demonstration of a gene-environment interaction leading to Alzheimer's or ALS or Parkinson's. I wanted to see a human analog. We'd been working in the places in these villages where we had the highest known levels of the neurodegenerative disease. I found Ogimi village on the very extreme northern tip of Okinawa that had no indication record of any of these diseases. that villagers know nothing about them. They were horrified when I told them about Alzheimer's disease. Um, they learn in Japanese in school, and they speak Okinawan, but they have their own village language, which is unique. And this is called Longevity Village in Japan because it has the highest number of people living over 100 years old known in the world. I've made 7 trips there. And I have to say, one of the greatest things that are happening personally after trip 7, the city council, Sue Severson's, she's mayor of Lamorinda, so that sort of mayor type. They said, please come see us. We're waiting for you. I went, and they gave me in Japanese like a plaque, and it said, "We've never met a foreigner like you that has shown us so much respect." I was so touched, and they are full partners in the research I'm going to discuss with you. I've been looking at their diet very carefully. This is just a lunch a lady prepared. They're eating 25 different species of seaweed. They even have an endemic type of citrus that's rich in serine. This is kombu. You probably could buy that right here in Lafayette. And tofu, they're off the charts in terms of L-serine content. To put that in perspective, although we make L-serine in our bodies, we know there's a variation between people. Some probably don't make enough. In our diet as Americans, we get 3 grams a day, roughly. These people are getting 4 times that. It's the highest recorded ingestion of serine in the world. And there's some other things I'll talk about in a second. This woman is a typical villager. She's not extraordinary. She's 98 years old. Here's the little film I took. She's 98. I asked her, can you touch your knees? And so she goes over and puts her palms flat on the tatami mat. Let me show you this. Here we go. Ready? Drum roll, please. I can't do that. Wow. Now I thought, well, maybe they're a bunch of acrobats. I said, can you bend backwards? Sure. That wasn't such a good idea, she says. She is 98 after all. Then I want to see how this neuron functions that goes from your spine down to your ankle. Did you know that? You have a single cell, a single neuron. It goes all the way down. I ask you to lift your legs up. Look at this. And it's not just range of motion, it's fluidity of motion. The people in this village move like ballerinas, and it's incredible. So I started trying to figure out what's going on. We brought all their diet back to Jackson Hole, analyzed it for serine content, and it's off the charts. So we took those 3 pieces of data, cell culture data, non-human primate data from the Caribbean, and human data from Okinawa, and the FDA approved our application for a clinical trial in 4 days after receipt, which I think is a record for the FDA. So we began our phase 1 trial for 20 ALS patients in Phoenix and here in San Francisco. These slopes mean that people are progressing very rapidly in ALS. And what we found was this, that at the dose of 30 grams per day, we had a highly significant reduction in progression. And this was a safety trial. We weren't expecting to see this. So we quickly moved to a phase 2 trial. It got messed up during the pandemic, so we didn't complete the full cohort of 50 patients. We had 28. But when we analyzed them, comparing them to historical patients, we're able to slow progression by 32%. And that's probably a low figure because I was so moved by some of the unhoused people that contacted me that I put them into the trial, got them up to Dartmouth, put them in hotels. And this was probably a dumb thing to do scientifically because they're not receiving standard of care. Imagine trying to manage a disease like this if you're unhoused. Highly significant. So we want to repeat this trial, start it over, and move forward. The final trial I'll talk about for a second is our phase 2 trial. This is an advanced FDA-approved trial for mild cognitive impairment. Mild cognitive impairment is a precursor to Alzheimer's disease. You can still hold your job, you can still probably drive the car, but you're just having a lot of glitches. And running the trial is just a man I respect so much, Dr. Gustavo Roman, who's maybe the best Alzheimer's doctor on planet Earth. He's head of the NANCE, National Alzheimer's Center. And he was in Guam about the same time I was. Dr. Edwin Vega, a neurologist, is our clinical coordinator. We are doing 100 patients there, and they're treated either with Alzheimer or placebo. It's randomized and double-blinded, so neither the investigators nor the patients know who's getting what, at Houston Methodist Medical Center. And we're very excited. Some things are happening in that trial, like people reversing out of the, in fact, they call it, so, we have people reversing out of the diagnosis. We've never seen that before. I said, well, you know what? That's the power of the placebo effect. Keep going. We won't know for sure. We won't have the data from this trial until early next year. And if there's anybody that you know of that's interested in the trial, let me know, see me after, because they'd have to fly 3 times to Houston, but that's possible to enroll people from outside of the Houston area. So we want to diagnose rapidly. It's taking the average ALS patient a year and a half to get a firm diagnosis of ALS. Alzheimer's diagnosis is equally concerning. So my team here is Dr. Bannock and Dr. Dunlop. Together, we've discovered a microRNA fingerprint for ALS. If you think of DNA as a keyboard, microRNA are the fingers that play that keyboard. They turn genes on and off. And from a single blood draw, we've now found 8 microRNA that completely define an ALS patient. Along the way, we want to distinguish it from other similar diseases, so we now have profiles for Parkinson's, multiple sclerosis, primary lateral sclerosis, et cetera. And we're just going to have this come out. It'll probably be out in 2 weeks. You'll see it in the news. But Oxford's publishing Brain Communications, our paper in which we announced that we've got a 98% accuracy in diagnosing ALS patients. So we're working now trying to find a diagnostic firm to commercialize this. We're not for profit. We're good at discovery, but we don't know anything about business. And there's a couple, they're talking to us. We welcome chatting with more. The idea is to move this intellectual property to a diagnostic firm. They will make the test available to neurologists throughout the world and general practitioners. And my real vision and dream is that about the time you get ready for a colonoscopy, and we all have our colonoscopy stories. Mine was, I went in and I said to the surgeon, would you mind doing this without anesthesia? And would you be comfortable? He said, well, it's not my comfort I'd worry about, it's yours. And I said, well, yeah, but I'm working on a drug and I don't want to forget where I'm at. So can we just please not just skip the anesthesia? So we did that. A male nurse could see I was in a little bit of discomfort. So he held my hand. I was so touched by that. Anyway, but about that time, you get a blood draw. It goes off. Most people never hear from it, but a few people, maybe 2.5, 3 per 100,000, they get hearing back. We'd like you to see a neurologist. Furthermore, our tests are so accurate that they can give the neurologist a little foot up on the diagnosis. Right now, diagnoses take a year to 1.5 years, and it costs about $5,000. We can do this for $150. And so it's going to be an aid for neurologists to rapidly diagnose their patients. And there'll be a little bit more in the news in probably about a week and a half, 2 weeks. Finally, we've invented a drug for advanced Parkinson's disease. Those that have Parkinson's are typically put on levodopa, 3 times 25 milligrams a day. It's great. It's a miracle drug. It works for a while. Then you have to jack the dose up. And you get about 5 dose escalations and it stops working. And unfortunately, in an advanced Parkinson's, after levodopa stops working, a number, about 40% of the patients go into a very frightening dementia. We've invented a drug that blocks that completely in monkeys. So if you have a monkey that's demented, can you see me afterwards? Because I know how to cure it. What we don't know is if it'll work in the clinic. So we've raised about half of the money we need to move a clinical trial forward, and we're beginning now to approach the FDA. And Houston's agreed to host the trial. So, and they've got a Parkinson's specialist down there. Please grab one of these newsletters if you'd like. They're sitting around the tables. Anybody that sends us $1, they get on our monthly newsletter. If you can't spare $1, rip one in half, and I'll rip a newsletter in half. But here's what we've learned about creating your own blue zone, creating your own blue zone based on our studies, intensive studies of these people in Okinawa. First of all, exercise. 30 minutes a day of a brisk walk has a significant reduction in Alzheimer's risk. All these women garden, start a garden, and there's something healing about gardening. Stay engaged. They get up every morning, they play their samsings, these little banjo things. They dance, they do Peter Rabbit type. I can't keep up with them. They're amazing. And they're building what I call a cognitive reserve. And this is really important. We know statistically from several studies that if you attempt to learn a second language, you don't have to learn it, you just have to attempt, you reduce your risk of Alzheimer's disease. Because it's like filling the reservoir with water. Stay engaged, be active in clubs like Rotary, be engaged socially, feed your mind, and be able to have this cognitive reserve. Oliver Sacks, who was my mentor in neurology, felt very strongly that the music has a powerful neurological effect. He found that his patients that can't walk could dance. Those that could not speak could sing. And I think he's on something there. I don't know of placebo-controlled. Well, maybe you could make a placebo-controlled trial. You could have like Tchaikovsky and then rap. And no, I gotta think this through. Anyway, listen to music that makes you happy and is uplifting every day. Take a point in doing it. And then most importantly, watch your diet. Several different carefully controlled trials show that people who adopt a Mediterranean diet, a diet rich in vegetables, fruits, antioxidant materials, not much red meat, very little, maybe a little fish, they have a up to 27% reduction in risk of Alzheimer's disease. And we think in our lab, and I don't have data for this, but sometimes my hunches are right, we think the olive oil is a really important component here. And we want to start working, taking that apart and molecularly, see what's going on. But if you change your diet, so what I'm saying is, can you reduce the risk of Alzheimer's? I'm saying yes. And it's some subtle lifestyle tweaks. Imagine serine for a second. Here's where we differ from the pharmas. And I respect them. I've consulted for half a dozen of them, but they're producing Alzheimer's drugs that cost $150,000 per year per patient. Most people can't afford that. They'll lose their pension, their house. Serine, you can buy it by the wheelbarrow full. It costs $32 a month for the doses we're giving. So my real dream, we don't know if it's going to work. If it does work, if it is efficacious, then the pharmas will license our IP. They'll probably call it some French cheese name like provolone. And they'll have a man and a woman sitting in tubs adjoining each other, looking out over Sonoma, and they'll hold hands and say, when you thought you were forgetting her name, she's still there, and they'll spend 10 times as much on the marketing campaign as we've ever spent on the research. And they'll charge the insurance companies out the wazoo. They'll come out with some sort of time release or whatever. Meanwhile, people that don't have insurance can buy it right out of the health food stores or off Amazon. People that don't have any money at all, I'll start conducting hikes for them, show them how to use wild plants that are rich in serine. So I'm really hoping it works, because it'd be great if it does. At this point, we don't know if it will, so please stay tuned. Our next steps, we want to get that diagnostic test out to neurologists as quickly as possible. CDC's just been wonderful. We've slammed 600 patient samples through our lab. We've got strong data. We want to finish up our mild cognitive impairment trial in Houston. That cost us $2.4 million. It's all paid for. That thing's great. We want to raise the remaining half of $1.5 million for the new Parkinson's drug trial, and restart the phase 2 ALS trial and do that again. So I want to thank you for being with me this morning. It's such an honor to be here. So grateful to be part of Rotary and for you to hold up a CICAD banner. Somehow you and I are going to connect, aren't we? Okay. And you can see more of this information at brainchemistrylabs.org. And if you're interested, take one of these newsletters, and it also has information how to stay in touch. So thank you very, very much for being here.